Okay, so in this video, I'm going to show you how to factor when the lead coefficient, so the number in front of the x squared term, is greater than 1. Okay, so basically when you see a number out front. The first thing you want to do when you see a number out front, first check if there's a GCF, okay? When I look at this problem, I notice I can divide out a 2. If this were just a plain factoring problem where there was no equal sign, you would have to write it as 2 times x squared minus 14x minus 32 equals 0. Because this is an equation, you are allowed to divide out that 2. So if I divide out 2 from this side, I'm going to have to do it from the other side, so we can get rid of it. So I have x squared minus 14x minus 32 equals 0. So let's find factors of negative 32 that add up to 14. So I'm just going to do a guess. So I have 2 and 16, 4,
2 and 16.
and 8. Ooh, looks like 2 and 16 might work. I notice that if both of these are positive, they're not going to multiply to negative 32. So that means one of them has to be negative. If I have negative 2 and positive 16, that's going to sum to a positive 14. I need a negative 14.
So negative 16.
So let's do positive 2 and negative 16. So x plus 2 times x minus 16. To solve for x, I'll need to set each binomial equal to 0. What you're trying to do is, if I were to make this number, x plus 2 represents a number. If that number were 0, when I multiply it by the other number, I'll get 0. So if this value were 0, so basically what I'm trying to do is, if x were negative 2, when I plug that in, I'll get 0, and it'll multiply through to 0. Thank you for the background noise.
Oh, sorry.
Here I have x minus 16 equals 0. When I add 16, I get x equals 16. So you get two answers here. X can be negative 2 or positive 16. The next method I'm going to show you, I'd like for you to take some time with this, okay? You'll need to practice it. This is a problem where, if you look at the lead coefficient, which is 3, I cannot divide it out. It is not the greatest common factor. So I'm going to do a method called the AC method. So what I'll do is I'm going to multiply the first and last term. So 3 times 4. 3 times 4 gives me positive 12. Factors of positive 12 that sum to 8. Let's find that. So I have 1, 12. That doesn't work. 2 and 6. Ooh, that might work. Okay, so what I'm going to do is split that 8x into two numbers, 2x and 6x. The reason I'm doing that, you notice I didn't change the value of the problem. I'm doing a method so that I can take out the GCF. So I'm going to group the first two terms and the second two terms. I always do it by addition. Okay, so if this 6 were negative, for example, you'd put it around the negative and just turn that in and write a plus sign. Okay, here it's positive, so I don't have to worry too much. So here I'm going to take out an x, and I'm left with 3x plus 2. And then the second term, I'm going to take out a 2, and you notice inside you're left with 3x plus 2. The whole goal is to make what's in the parentheses the same. So when I divide out 3x plus 2, you're left with x plus 2. I'm not done. I need to find the value of x that would make this binomial equal 0. So let's solve that on the side. What would make that equal 0? Well, I'll subtract 2. This is just a linear equation, which we should know how to do. So x is negative 2/3. So if x were negative 2/3, the equation would equal 0. Here, x plus 2. I think you guys know how to solve that. I think you know how to solve that. X would have to be negative 2. So sorry if this went fast, but we've reviewed this already, but I wanted to make this as a resource for you. Let's do one more problem where you have a negative, okay? So let's make this 1/2 minus. Actually, I'm going to make this into Okay, So here I have 4x squared minus 8x minus 5. I'm just going to make this a factoring problem, not an equation. So at first, what I need to do is multiply my first and last term, which gives me negative 20. Now I need to find factors of negative 20 that add up to negative 8. So 1 and 10, 2 and 10. Oh, that might give me negative 8. One of these has to be negative. So if it were negative 2 and positive 10, that would add up to positive 8. How about positive 2 and negative 10? That seems to work. So I'm going to rewrite this problem as 4x squared plus 2x minus 10x minus 5. I did this problem on purpose so you can see what happens when this isn't a negative. So let's group these. So I'm just going to put a parenthesis around that minus sign. I'm just going to write plus. Okay, you can't randomly just change the problem to multiplication. So here I'm going to take out my GCF, which is 2x, and I'm left with 2x plus 1. Here I'm going to take out a negative 5. Here's a hint. If this number is negative, that means you're going to take out a negative, okay? Usually. So 2x plus 1, it changes the signs when I divide out that negative 5. If you notice, the numbers in the parentheses are exactly the same, so I can take that out, 2x plus 1. And when I divide that out, I'm left with 2x plus negative 5, which we can just write out as 2x minus 5.